Hi, my name is Ali, and today I'm gonna present the coin toss simulation. The structure of this program is divided into two small programs. One will simulate the action of flipping the coin n time, and one will repeating that action for m time. The function we're going to use in this program including the random module, the for loop function, the if-else function, assigning variable, multiplication, addition, division, list, accumulator, and print. So the program number 1 will be tossing the coin n time. We're going to need a random module because what the random module do is we get us a random number, and we're going to use that to simulate the action of tossing the coin. Since tossing the coin gives you a random result, we're going to use this random module to decide whether we're going to get a head or a tail. And here the side tag for the random function. Here is the code for the first function. We take the number of times we're going to flip the coin, the probability that we're going to get a head, and set up two accumulator, one for the number of head and one for the number of tail after we flipping the coin n time. Then we go through loop for n time. If the random give us a number that's smaller than the probability of head, then we're going to add 1 into the head accumulator, otherwise we're going to add 1 into the tail accumulator. And then we're going to return the number of head and the number of tail after we flipping the coin n time. And the function number 2 is repeating the coin toss action for m time, big M time. It's going to take the number of time we flip the coin, the probability we're getting the head, and the number of time we're gonna repeat the action. Instead of a list with n plus 1 term, and all the term in this list would be 0. Then here the action of flipping the coin n time, and we're doing that for m time. That's why we need to use a for loop here. And what this thing will do is, for example, if you have after you flipping the coin for n time, you have, for example, 2 head and 3 tail, it's the combination. Then what it would do, it go through the 4 term in the list, and is gonna add 1 into it. What is the 4 term in the list? As my definition, my assumptions is that this will be n plus 1 term, right? So it's gonna be, let's say we flip the coin 5 times. So it's going to be 0 head, 1 tail, 0 head, 5 tail, 1 head, 4 tail, 2 head, 3 tail, and then so on. So if this one is equal to 3, then this goes to the 4th term, which is 3 head and then 1 tail, 3 head and 2 tail, and then add 1 to it. So at the end, we're going to keep track of how many combination of the number of head and the number of tail that we're getting after we've done that for 1000 times. And I set up a sum equal to 0 here. I use the for loop to go through the loop for the length of the list here, because I want to go through all of the combination and calculate the probability that I getting that combination when I do the experiment for 1000 times. So the probability of getting that combination, I said is PH, is the probability of getting the combination with the number of head and the number of tail when we're flipping 5 times and then doing this for for big M time. So let's say we go through it for the first time. K would be equal to 0, and the combination of getting the first is going to be T0, which is the third term in the list, which is the combination of 0 head and 5 tail in this example that I give. And then it will be divided by 1,000 times, which is the big M, as I say. And then what it do here is going to print out the probability of getting that combination of, let's say, 0 head and then 5 tail. So if we have K head, then we're gonna have N minus K tail. That's what's simple to understand. Then I'm gonna add that probability of getting one combination to the sum and print out that sum. It's just to make sure that all the probability of getting all of the combination was sum up to 1, and if it's sum up to 1, then I know that my calculation was correct. And here's the trial run that I did earlier. As you can see, we're tossing the coin 5 times. The probability of getting the head is 0.5, which is the fair coin, and we're doing this action for 1,000 times. And here's the probability of getting the combination, and this is all the combination I'm getting, and all of the probability is all sum up to 1. So I know that my calculation was correct. And all of these cases, for 48 cases with combination of M time and then small n time, is all printed here. And for the discussion of how to tell whether a coin is fair or not, and here's my observation, and what I conclude from it is that let's say you toss the coin for 5 times, right? You're gonna divide it by 2. It's just you just take the middle point. So 5 divided by 2, so maybe you're gonna get 2.5 head and 2.5 tail, but we cannot really have 2.5 tail and 2.5 head, so it's just gonna somewhere around here, like 2, 3, 3, 2. So let's say our midpoint somewhere around here, and you can see the number is symmetric through that middle point. You see, 2 head, 3 tail, 3 head, 2 tail. The number is the same. As you go further away, 1 head, 4 tail, 4 tail, 4 head, 1 tail. The number is close, and here is the number is not the same, but it's close. Compared to a not fair coin, let's say here 0.6 is how here our middle point. As you can see, as we go further to the right of the probability of getting the combination, it just have a big gap. As you see here is 0.251, and here it's just 0.087. Is not symmetric through the middle point. The number get bigger, have a bigger gap as it go further away from the middle point. And take a another example is here to make it clear. Say you toss a coin for 10 times, then the midpoint will be you getting 5 head and then 5 tail, which is here. Is here for a fair coin. The number is pretty much the same as you go further away. Is symmetric through that middle point. But as for a non-fair coin, you can see the number as you go through the left and the number as you go through the right. It's just not symmetric. It's have a big gap between it. So that is my opinions and my conclusion from the observation. That's how I can tell whether a coin is fair or not. And here is the complete code that I write in Python for the project, and here the trial run that I did earlier. And yeah, that's all. I think that's for my presentation, and thank you for listening.